For decades, Boeing dominated the skies with jets and endless resources, until a lesser-known European upstart called ATR quietly took over regional air travel using outdated propellers. In the world behind how a tiny plane maker outsmarted Boeing with propellers, $2 million in savings per plane and a 35% cut in emissions turned industry logic upside down. How could a tiny firm outthink the American giant everyone else feared? The answer begins with the one market Boeing never saw coming. A TR began as an unlikely challenger in a world ruled by giants. Founded in 1981 as a joint venture between France's Aerospatiale and Italy's Air Italia, ATR was never designed to compete head-to-head with the likes of Boeing. The company's focus was narrow: build practical, efficient planes for short-haul routes that most major manufacturers ignored. Its headquarters in Toulouse, far from the sprawling campuses of Seattle or Chicago, reflected a different scale. A handful of engineers and managers, not armies of executives and lobbyists. Boeing, meanwhile, had set the rules for commercial aviation. For decades, it shaped airline fleets with aircraft like the 737 and 777, defining what it meant to fly modern. Alongside Airbus, Boeing formed the duopoly that supplied nearly every major airline on Earth. The company's resources seemed limitless: billions in annual revenue, global supply chains, and a reputation for technical dominance. In this environment, smaller manufacturers were expected to survive on leftovers, if at all. Yet ATR saw opportunity in the cracks of the system. The company's early turboprop models, the ATR-42 and the ATR-72, targeted regional routes too short or too thinly traveled for big jets to make money. These were not glamorous city pairs or long-haul transcontinental flights. They were the links between small towns and regional centers, routes where every cent counted and every empty seat was a liability. While Boeing and Airbus raced to build faster, larger jets, ATR doubled down on propeller-driven planes. This decision seemed out of step with the industry's obsession with speed and prestige. But for airlines struggling to keep marginal routes alive, ATR's approach offered something the giants could not: a machine built for survival, not spectacle. The contrast was stark. Boeing's brand carried the weight of national pride and global influence. A TR, by comparison, was a quiet specialist, focused on a single mission. It did not have the luxury of chasing every market or the pressure to satisfy Wall Street. Instead, it listened to regional airlines who needed reliable, affordable planes to connect smaller communities. Needs that rarely made headlines, but mattered deeply to those who depended on them. By the early 2000s, the commercial aviation world had split into two camps: the jet duopoly at the top, and a handful of niche players fighting for scraps. A TR stood out not for its size or marketing budget, but for its willingness to serve a market the giants barely acknowledged. The company's survival depended on finding value where others saw only risk. As Boeing's jets grew larger and more advanced, ATR kept refining its turboprop designs, betting that the fundamentals of cost, efficiency, and access would one day matter more than image. The stakes were clear. If ATR failed, regional air service would shrink, and the duopoly would tighten its grip. But if this small firm could prove that old-fashioned technology still had a place, it might just change the rules of the game. Across the world's air networks, a quiet but crucial gap had formed, one that most major manufacturers failed to notice. Between sprawling hubs and big city runways, thousands of short-haul routes connected small towns, islands, and remote regions to the economic mainstream. These flights did not attract headlines or premium fares. Instead, they demanded a different kind of aircraft, one that could carry 70 to 90 passengers, land on runways as short as 3,000 feet, and operate profitably even when every ticket sold mattered. For regional airlines, the challenge was always the same. Jets, with their thirst for speed and altitude, were overbuilt for these short hops. On a 200-mile route, a jet would barely reach cruising height before descending again, burning fuel at rates that made the economics break down. Airports in smaller communities often lacked the long runways and infrastructure needed for jet operations, shutting out entire regions from reliable air service. The result was a growing patchwork of unserved or underserved routes, links that disappeared as jets replaced older, more adaptable planes. Turboprop aircraft, once seen as relics of an earlier age, offered a technical answer that fit this profile perfectly. Unlike jets, modern turboprops are engineered for maximum efficiency at lower speeds and altitudes, the exact conditions found on regional flights under 500 nautical miles. Their propeller-driven engines convert more of their power into forward motion at these lower speeds, delivering up to 30 to 40% better fuel efficiency than jets on the same sector. For airlines, this meant lower fuel bills, lighter maintenance requirements, and the flexibility to serve routes that would otherwise be uneconomical. The ability to operate from short runways was not just a bonus, it was essential. Many regional airports have strips barely 3,000 feet long, a distance that would force jets to take off half-empty or skip the stop entirely. Turboprops like the ATR-72 can take off comfortably in these conditions, opening up dozens of city pairs that jets simply cannot reach. This technical edge gave regional carriers a way to maintain frequency and connectivity, even as larger airlines consolidated around major hubs. For passengers, the difference is often invisible. Modern turboprops offer quiet cabins, quick boarding, and ride comfort on par with jets. But for the airlines and the communities they serve, the impact is profound. Where jets struggled to make money, propeller planes could keep routes alive, or even create new ones. In this overlooked corner of the market, engineering for the specific mission profile, short distances, modest passenger counts, and tough infrastructure became the decisive factor. The old logic of faster is better gave way to a new reality. The right tool for the job is the one that keeps people connected, no matter how small the town or how short the runway. For regional airlines, the math was unforgiving. On a typical 300-mile route, the cost per available seat mile, CASM, became the ultimate battleground. Turboprops like the ATR-72-600 delivered figures in the range of 12 to 15 cents. Comparable regional jets, even the most efficient, hovered closer to 18 to 22 cents. That spread meant an airline operating a fleet of 20 turboprops could save up to $2 million per aircraft every single year just on operating costs. Fuel bills alone told a stark story. The ATR-72-600 burned about 2.6 liters per seat per 100 kilometers, while a regional jet on the same route would consume nearly 40% more. Maintenance, too, tipped the scales. Turboprops required less frequent overhauls, and their simpler systems meant fewer hours lost to downtime. They dictated survival for airlines serving communities where every ticket mattered. A regional carrier's chief financial officer, faced with razor-thin margins, could look at the bottom line and see that breaking even on a half-full propeller plane was possible. On a jet, the same flight would bleed red ink unless nearly every seat sold. As the industry's oil shocks hit, most dramatically in 2008 when prices spiked to $147 a barrel, airlines that clung to jets on short routes faced immediate crisis. Internal memos from that period show boardrooms freezing jet orders and scrambling to negotiate with turboprop manufacturers within days. Boeing, meanwhile, made a pivotal decision in the early 1990s. After years of mounting losses at its Canadian subsidiary de Havilland, the company chose to exit the turboprop business entirely. The sale, completed in 1992, handed the Dash 8 line to Bombardier and allowed Boeing to redirect capital toward its flagship jet programs, 777 and later, the 787. Executives justified the move by pointing to a $636 million loss over 5 years and a strategic need to focus on high-margin large aircraft. But the internal debate was not without warnings. Leaked correspondence from the time shows some managers cautioning that abandoning turboprops would hand the 70 to 90-seat segment to competitors in Europe. The board, focused on Wall Street and long-haul prestige, overruled them. The consequences of that decision rippled through the industry. With Boeing's exit, regional airlines lost a major supplier of small, efficient aircraft. The company's attention shifted fully to jets, leaving a vacuum that smaller manufacturers like ATR were poised to fill. For Boeing, the numbers may have looked right in the quarterly reports. For regional carriers, the economic reality was inescapable. Propeller planes kept routes alive, while jets threatened to shut them down. Regional airlines operate on the edge of survival. Profitability. Between 2 and 5% is a typical margin, leaving almost no room for error. A spike in fuel prices or a few empty seats can turn an entire route unprofitable. For these carriers, every decision is scrutinized, from the routes they fly to the aircraft they choose. The reality is stark. Jets promise speed, but on short hops that speed comes with a punishing cost. ATR engineers understood those pressures firsthand. In the early 2000s, as fuel prices climbed and regional networks came under strain, the team in Toulouse faced a crossroads. The industry chased faster, flashier planes, but regional operators kept asking a different question. How do we keep flying when every cent counts? ATR chose a different answer: efficiency over speed. That philosophy drove the design of the Series 600. It was built not for prestige, but for survival. The Series 600 introduced upgrades aimed squarely at the daily pain points of regional airlines. The new Pratt & Whitney PW127M engines delivered up to 10% better fuel efficiency than previous models. Lighter airframe materials cut every unnecessary kilogram, shaving fuel costs with each flight. The flight deck was overhauled into a digital glass cockpit, streamlining operations and reducing pilot workload. Maintenance became simpler and faster with modular systems and improved diagnostics, cutting downtime between flights. The cabin was reimagined with lighter seats, improved soundproofing, and energy-saving LED lighting, all to lower operating weight and enhance passenger comfort. Every feature was engineered with a single goal: make regional routes viable even when passenger loads dipped or oil prices spiked. The ATR 72-600 can take off from runways as short as 3,000 feet, opening airports that jets cannot touch. Its fuel burn over speed ethos meant that on a 300-mile leg, airlines saved thousands of dollars per week compared to running jets. For operators facing razor-thin margins, these savings were the difference between cutting a route and keeping a community connected. Behind the scenes, ATR's approach was shaped by relentless debate. Engineers like Fabrice Vautier and Daniel Solakian argued for prioritizing cents per seat mile over cruise speed, while marketing pushed for a faster airplane to match Bombardier Q400. CEO Stephanie Mayer ultimately backed the engineers, convinced that real-world economics would matter more than headline numbers. That decision set the Series 600 apart, a plane designed for the realities of regional aviation, not the fantasies of the showroom floor. Airline order books began to tell a new story. Since 2018, ATR delivered 661 aircraft to carriers on 6 continents, a figure that outpaced every other manufacturer in the regional turboprop segment. Airlines that once relied on jets for short-haul service Silver Airways in the US, Air New Zealand, carriers in Scandinavia and Southeast Asia, shifted their fleets to ATR models, citing operating costs that fell by as much as 30% overnight. In Europe, regional planners reported opening up city pairs that jets could not serve profitably. Air New Zealand's network team logged 14 new routes within 2 years of switching to ATRs, routes that would have been financial non-starters with jets. The numbers behind these moves were impossible to ignore. In the same period, Bombardier and Mitsubishi exited the regional turboprop market entirely. Embraer, focused on jets, left the 70 to 90 seat propeller class uncontested. Only ATR remained, and airlines responded by making it the default choice for new regional aircraft. Independent fleet databases confirmed the trend. ATR now accounted for 27.6% of all new regional aircraft deliveries worldwide since 2018, a market share built on relentless adoption rather than splashy marketing. As the momentum grew, Boeing's absence became more obvious. Internal documents from the late 1990s had warned that selling off its turboprop business would hand the segment to European rivals. Still, Boeing's leadership treated the regional market as a side note, a niche too small to justify new investment. With no in-house turboprop expertise or supply chain left, the company watched from the sidelines as ATR filled hundreds of orders that once might have gone to Seattle. Industry analysts began to call it a multi-billion-dollar market left on the table. For ATR, each delivery was more than a sale. It was proof that a small, focused company could win by serving needs the giants had written off. The competitive landscape, once defined by Boeing's shadow, now had a new center of gravity. Airlines, planners, and communities were not waiting for the next big jet. They were lining up for a propeller plane built for their world. Airlines and regulators began to scrutinize not just the economics of regional aircraft, but their environmental footprint. On short-haul routes, the difference between jets and turboprops became impossible to ignore. The ATR 72-600, for example, produces around 70 grams of carbon dioxide per passenger kilometer. A comparable regional jet emits 108 grams on the same sector. That 35% gap is not just a line in a technical report. It is a real-world advantage that helps airlines meet tightening carbon targets and win over eco-conscious travelers. In 2019, the ICAO assembly highlighted these numbers, and Scandinavian carriers used the data to negotiate lower landing fees at 3 major airports. This environmental edge is not theoretical. It shapes airline decisions and route maps. In Europe, regional planners have cited lower emissions as a reason to expand propeller-powered routes, especially as governments push for cleaner, more sustainable air travel. Airports in Norway and France now offer incentives for airlines operating low-emission aircraft, and ATR operators have been among the first to benefit. The appeal goes beyond regulatory compliance. It is a selling point for passengers and communities who want to see aviation pull its weight on climate action. The infrastructure story is just as striking. Turboprops like the ATR 72-600 can operate from runways as short as 4,000 feet, opening up airports that jets simply cannot reach. At Guernsey Airport in the Channel Islands, the switch to ATRs allowed daily flights to jump from 2 to 6, connecting more people and boosting the local economy. In Alaska, Aleutian Airways restored service to remote communities using ATRs, linking towns cut off when jets became too expensive or impractical. Today, ATRs reach more than 60 countries, with more than 100 airlines relying on these aircraft as the backbone of their regional fleets. The environmental and infrastructure advantages have become inseparable from the business case. Airlines are not just saving money, they are gaining access, meeting regulatory demands, and offering service where jets cannot. In a market shaped by constraints as much as opportunity, these non-economic benefits have sealed ATR's dominance in the segment. Right now, over a quarter of all new regional aircraft worldwide are ATR turboprops, proof that efficiency still beats prestige in the real world. As airlines face rising fuel prices and growing environmental pressure, the overlooked solution becomes the industry standard. Sometimes the future isn't about what's new, it's about what works. The skies remind us, innovation isn't always the loudest engine.